Hi everybody. In this problem, we have a cannonball that is projected at an angle of 60 degrees with an initial speed of 15 meters per second. And we are asked to determine the maximum height and the horizontal range. So the question, the ball is projected at an angle of 60 degrees with a certain speed v naught, which is equal to 15 meters per second, and we have been asked to calculate the maximum height and the horizontal range r. This is a very beautiful question. Now I'm going to give you some tricks in how to handle this kind of problems in projectile motion. Now, whenever you're given a problem in projectile motion, there are just a set of 4 equations that you can actually use in solving any problem that is given to you in projectile motion. And I'm just going to show you that and exactly the steps and the process that you will follow in order to get this going. Now so we have a projectile that is launched with a certain speed v naught So we're going to analyze this a little bit just for me to give you a little background on projectile motion. Let's superimpose our coordinate system. This is our x-axis and this is our y-axis. So let's call this angle theta. What this exactly means is we can resolve the initial velocity into 2 components. You have the component along the x direction, this will be v naught cosine theta, and the component along the y direction, this is v naught the sine of theta. Now just as a review, if you draw this triangle, this is v naught. You have the x-axis, you have the y-axis. This is v0y, and this is v0x. This angle right here is theta. We will use a simple trigonometry trick called Soka-Tor. Now, S stands for sine of theta, which is going to be equal to the opposite VOY divided by V naught, which means that VOY is equal to V naught sine theta. Let me go check to see what the baby is crying. So similarly, sorry about that, my baby was kind of crying, and she was just lonely out there. So similarly, the next thing that we will want to do is look for the x component. Cosine of theta, it's the opposite, which is, no, the adjacent, sorry, which is VOX divided by the hypotenuse, which is VO. That would mean that VOX is equal to VO cosine theta. this right here gives us the initial velocity in the x direction and the initial velocity in the y direction. Now, if we, for example, draw the projectile at this point, this is the direction of the velocity. We can split it into two components. You have the x component Vx and you have the y component Vy. Similarly, if we draw the object right here, the direction of the velocity is in that direction. This is Vx and this is Vy. What do you realize? When the ball is actually going upwards, the vertical component of the velocity is pointing upwards, which means that it's positive. When the ball is going downwards, the vertical component of the velocity is pointing downwards, which means that it's negative. Now, at all times, the horizontal component is always positive, which means it's always greater than 0. It's something you need to take note of. So, whenever you're given a projectile motion, the very first step that you need to do is to resolve the initial velocity into its x and its y component, just like we have done. Now, step 2 is to resolve the velocities v into Vx and Vy. Keep in mind, this is important, that the acceleration in the x direction is 0 and the acceleration in the y direction is negative g. Why is this the case? Just like I said in my previous lecture video, the only